So today I want to talk about data operations, and one of the reasons why I think this topic is important to just kind of mention, at least in passing, is that as large enterprises are maturing in their data-driven journeys, they need to focus on operationalization of their data operations and not the experimentation, right? So shifting from the lab to bringing these types of principles into your core business. And the entire talk is going to be centered around French fries, okay? And the main reason why I'm going to be talking about French fries is that they asked me to be very tactical, and I want you to leave with a very tactical analogy to go talk about something that usually flies 10,000 feet over people's heads, and also, hopefully, it'll get kind of the mood going and lighten up for food afterwards. So my goal is to essentially make sure that by the end of the night, you think that this approximate equality holds true, which is that potato processing is roughly equal to data operations, okay? And essentially, by analogy, if you want to learn about great data operations, well, we're going to have to learn about potato processing from the king of French fries, McDonald's, and hopefully they don't dock us on using their logo here, but really shout out McDonald's, you make the best fries in the world. So the analogy is pretty simple, right? Making French fries starts like this. You take a potato, you peel it, you slice it, you dice it, then you blanch it, you fry it once, you fry it twice, and then you get this golden, crispy, salty, delicious snack. Data is essentially the same thing, okay? So you take data, you slice it, you dice it, you make sure that you have the right thing, you select exactly what you need, right? Pick out the features that you're going to use for your analytics or your machine learning, and then eventually you package up your data into a product that you're going to hand off for someone to do the final fry, which is usually your data scientists and your analysts. And all of the kind of potato processing side of the data equation is done by a different group, which is often called the data engineers. Okay? So hopefully this is at least somewhat believable at this point. And getting this process down and well means better, faster decisions across your entire enterprise. And because we're now running the vast majority, or so claiming to be doing so, of the decisions based off of data instead of speculating about the world, it's important to get these types of operations correct and get really, really good at them. So I've got a video. Hopefully this will work. Do we have internet? Sweet. Oh, we also have sound. I'm going to mute it and just talk over it because I have a much nicer voice than that guy, apparently. Totally not. So as you see, the two main things I want you to focus on here are the flow of the potatoes throughout this entire system, right? The potato is always, always, always in motion. It never stops. And then the next component that I want you to focus on is the automation, okay? And those are going to be apparent as we go through. As you can see, there's a freaking potato cannon that is cutting French fries, okay? That's an important part of the process. Then the French fries being sliced, put on conveyor belts. It's actually getting washed right here. Then there's going to be a super giant robot that's actually going to pick them out mid-flight and kill the bad ones. This is the robot. Let the good ones through. And then eventually we're going to go through kind of the blanching step, the first fry, and then the second fry. So I'm going to hopefully slow down a little bit and let you guys kind of enjoy the potato motions as they go through. I'm pretty hungry already. Also, the handle in the early slides is my Instagram account, not my Twitter account. I have very few things to say in words. I talk through food. So this is the first fry. And then what you'll notice is it's interesting. The first fry happens centrally within the factory, but after that, the French fries get packaged up, frozen, and then shipped off to the individual franchises to be processed at kind of the last mile of the potato journey, which is in the McDonald's franchises. And so we're right about done. Cool. Now we're going to throw some salt on these bad boys, and then you can just eat them. All right. So now let's take a look at this entire process in kind of a bird's eye view. You take potatoes from the field, load them onto trucks, bring them to a central processing plant, slice them, dice them, blanch them, fry them twice or once, package them up, freeze them, send them to the franchise. Eventually, some cook in a line will be using appliances to do a final fry on your French fries and kind of load them up for consumption by the end user. So now let's layer on our data operations analogies. You could think of, I was pretty clear that the potatoes are the data, the fries are the insights. Now the trucks in a typical enterprise data operations setting are going to be your connectors, the things that connect to the actual data that you're going to be consuming. The lines that lead to this central processing place today tend to be message queues and streams. You could think of Kafka as a great example of those things. Then the processing plant, we think of as a new class of tools that are emerging in the enterprise, which we call data operations platforms. And these are platforms where the data engineers go to do their best work, right? We're not talking about an Informatica or Talent that's really trying to simplify the work down so that anyone can do it, but really a platform for the most sophisticated data engineers to be force multipliers within your businesses. Finally, the last part of the truck, again, connectors that ship this data out to the front of the house, where the data scientists, which could be the cooks or the analysts, will use this kind of last mile of the journey tools to be able to process your data, fry them up, and then have them consumable by your business people. And here the tools could be like a Trifacta or Paxata, really great kind of Excel on steroids for cleaning and prepping your data, and then any sort of analytics tool that you've got in the portfolio of assets that you're purchasing. And if you're a big bank, you're probably doing one of each, so you shouldn't be worried about that. So now I'm going to shift gears a little bit in terms of lessons that we've learned working with some of the world's largest businesses as they go through this journey of operationalizing their data operations. Lots of ops there. But the main thing is don't prematurely scale, right? So the lesson here comes from McDonald's. I guarantee you the first McDonald's did not have a giant potato gun for chopping their potatoes. You probably don't need a giant potato gun for cleaning and prepping your data if you're very, very small scale. So make sure that your investments are proportionate to, one, your understanding of your outputs, right? Are you making French fries? Are you making burgers? So are you going to be predicting or explaining the world? You actually have to nail that down before you start investing in these technologies. And the next piece is kind of looking at where people have invested in the past, and we've seen quite a few customers that come to us and tell us, hey, can you operationalize my big giant warehouse? We say, well, you've probably gathered too much inventory for this to be operationally feasible, so let's start from scratch and think about how we clean up your architectures and make sure that you're making sane investment decisions. So today we see companies investing in the giant data lakes and the massive, massive pub sub queues without necessarily having a clear direction of where it's going. And we say, hey, take a step back, think about the bigger picture, and let's think about these problems together. We built a tiny little framework. So we started hiring consultants as salespeople and stuff. I used to hire lawyers as salespeople. Matt knows that that's an experiment that has succeeded and also is turning out to not be very scalable. So the main thing that we kind of think about when thinking about data problems and data challenges and asking ourselves, is this something that I want to actually operationalize and invest in building kind of factory-like things around these data assets, are kind of four little things that you need. One is large number of sources from a variety of domains with a significant enough volume and a need for quick iteration. And the iteration piece is essentially where my analogy just breaks down, so I'm coming out here and kind of laying it bare. I've talked about building physical factories that cost billions of dollars to build and is really, really long to actually get right. Because I'm talking about data operations, we live in the digital realm, so it's actually possible to invest in these technologies in a very iterative and agile fashion, and that's how we prefer to engage with our customers. But essentially, just to put this in context, if you should just go watch the GTC demo by Jensen Huang. the CEO of NVIDIA. He names drop our largest customer. I won't do it here because that was a mistake. But the folks there are processing hundreds of thousands of data sources per month from a handful of domains, about a terabyte of brand new data being generated, and they needed to cut their iteration down from 8 days to 4 minutes, and that's what we've been able to accomplish with these guys. They've shown ROI of hundreds of thousands of dollars per day using our platform and kind of cleaning their assets for operational decisions. So, well, that's an interesting wonky thing. I have no idea what it says under there. So a great potato processing plant has essentially two interesting properties, flow and automation. I asked you guys to pick those things out. Turns out that great data operations have the two same properties, flow and automation. So let's kind of think through some of the properties of flow. One of the main things that we like to see within our customers is connectors that don't really require a nuanced understanding of the implementation details of the data. What that means is the data engineer shouldn't give a shit if it was a JSON object, a Hadoop cluster, a relational database. They should just be able to get work done. We have an interesting property baked into our systems, which is a back pressure stream from connector to connector. It's getting into the weeds a little bit in terms of details, but what that allows you to do is just not really have any one part of the system outrace another part, and therefore create resiliency in your data pipelines and making sure that things don't break. And then the last piece is a uniform transformation model, which I think is incredibly important, which is that the data engineer should only have to really learn one set of transformations ever, and they shouldn't have to go back and relearn things over and over and over again. There should be one way of transforming data, and that's it. That helps with shareability, discoverability, and all those things. And then the next piece is around automation, and just, I guess I'll plug a little bit. We combine both flow and automation as a company for data engineers. And so that's the plug. But for optimal automation in a data pipeline, you should be able to create extremely simple models that help automate redundant tasks within your data engineering processes, as well as complex ones if required. So we support both simple pattern matching as well as complex machine learning models. The vast majority of the assets that you have today that drive a lot of value are both in structured and unstructured data. So a tool should be able to deal with both. And the last piece is you should not need a machine learning PhD to operate a data engineering or data operations platform. You should just be able to get your work done. It would be a massive waste of resources to make sure those people had PhDs. So, tying it all together, went super fast because I was short on time. I had to cut my demo, I had to do a whole bunch of things, so I apologize. And we're right on time. So I hope that I've gotten to convince you that potato processing is roughly equal to data operations. If I failed, please come and talk to us. My co-founder's here, my wife is here. She probably can't help with this because she's a nurse. But just please come talk to us. We're happy to engage. And hopefully this was somewhat entertaining. To talk more, please shoot me an email or go on my Instagram account, Timbytes. You can request your home-cooked dinners with us, of which Matt is yet to attend. So, thanks all. Is that your first food talk?
With that? Yes, first. Yes, first use of French fries, which at some point was my nickname when I arrived in this country. So you started plugging a little bit. Do plug. So, like, very specifically, what do you guys do?
So, interestingly enough, it's a question that we still struggle to answer today. The best answer I've got for you guys is essentially that whole analogy. But really, it's focusing on the first mile of the data journey and providing tools for the data engineers who play in that first mile to be force multipliers in their organizations. And what that ends up looking like is an incredible SDK to build data pipelines that scale, that are easy to use, that are shareable, discoverable across the entire organization. and then really sophisticated machine learning models that allow you to automate redundant tasks like schema mapping, making sure that you are building resilient data pipelines when kind of the largest customer that we work with is actually a telecommunications provider. And interestingly enough, their tool, the assets that they have on their networks tend to change schemas from time to time, which makes building an ETL pipeline incredibly difficult because everything breaks. So they use the machine learning within our platform to help build resiliency into those workflows. So the unsexy side of things is just the first mile of the data journey is what we help build tooling around.
We're a little bit over time, so like maybe 1 or 2 questions. All right, I'll have plenty of questions otherwise.
We've got one up front.
Sometimes the data structure can change over time, and how do you deal with that?
That's a beautiful question. So I talked about a uniform model for kind of each one of the data sources, right? For us, that's a tiny little graph. So most people who try to kind of remove the format from the data just build these giant graphs. For us, we build a collection of graphs. So whenever a data point comes in, it becomes just a series of nodes and edges, and it's a collection of each one of these for each one of the connectors. And so what we did is kind of abstract away the data format to a very basic mathematical representation of what that data should look like. And then you can do interesting things like use machine learning to classify each one of the data points. And then what you end up kind of living in is a world where you can operate on the data based off what the machine learning model is classifying instead of based off the implementation detail or the structural detail of the data itself. So you could do things in our platform like filter out PII as it comes in without ever needing to understand the implementation detail of that data, which is kind of a cool way. Highly recommend a demo.
All right, one more.
We got one more.
Hey, Tim. Thank you. Definitely appreciate the talk. I really like the analogy. The question I have is, how do you provide the solution? Is it on-prem? Is it on cloud? Is it platform? Or is it something that you come in and build out for your clients?
It's a beautiful question as well. All beautiful questions. It's great. So it's a mixture of everything. We very, very early on in our company built some great capabilities around deploying bare metal Kubernetes and just kind of being able to operate in pretty much any environment. And I don't know if Algorithmia came out, but Kenny still calls our VP of Eng, and we trade notes on how to do this at scale and within large enterprises. So we're agnostic to the environment. We've got on-prem deployments on the edge, like centrally in people's VPCs. So we made the stupid, expensive decision of just handling everything. In the end, I think that's paying out with the class of customers that we work with. So it's Kubernetes is kind of the orchestration layer, series of microservices that sit on top of that that help you with creating a whole bunch of objects, but also running streams at scale.
All right, on this note, I think we're exactly on time.
Sweet.
Thank you, very well done. Thank you
man.
very much, appreciate it.
Thanks, man.